Welcome students for the physical chemistry lecture paper number 11. Up till now we have completed 4 units. The first unit, it is the elementary quantum mechanics. Then second unit that you have studied, that is the spectroscopy. Third unit, that is the photochemistry. Fourth unit, it is the solutions. All these units you have learned, and the last unit of this term, it is the electromotive force. It is also abbreviated as EMF. Remember, this chapter, it is the last chapter, last unit of your syllabus. And the subpoints in this chapter that you are going to study, that points are here. The first point, it is the introduction. Second point, thermodynamics of electrode potentials, Nernst equation for electrode and cell potential in terms of activities, and convention regarding the reduction potentials to be used in this chapter. The whole potentials we have to express as a reduction potentials in this chapter. This is the important note before study of this chapter. You have to express all the potentials in terms of reduction potentials. Remember that. Here the chapter electromotive force, it consists of in all 7-8 points. The first point, here it is introduction, thermodynamics of electrode potential, Nernst equation for electrode and cell potentials in terms of activities. Then the next point, here it is EMF series. What is the EMF series and how the elements in the EMF series they are arranged? It is studied in the EMF series. Then the next point, here types of electrodes, and you have to study all these types in terms of description and construction, representation, half cell reaction and EMF equation. And for your study there are 5 types of different electrodes. The first type, here it is metal ion electrode, amalgam electrode, metal insoluble salt electrode, gas electrode and oxidation reduction electrode, or it is also called as reduction electrode. Then the next point, reversible and irreversible cells, chemical cells without transference, then concentration cells with and without transference. Then the next point, liquid junction potential, its origin, elimination and determination. And the next point, here it is equilibrium constant from cell EMF, determination of thermodynamic parameters such as delta G, delta H and delta S. Then the next point, here applications of EMF measurement, and for your study there are only 2 applications. The first application, here it is determination of pH of solution by using hydrogen electrode, and second the solubility and solubility product of sparingly soluble salts based on the concentration cells. And here these are the some reference books that you have to follow or use for the study of physical chemistry. Here I am using this book Physical Chemistry by G.M. Barrow, and this book is edited by McGrew-Hill Publication. Then the second book, here it is University General Chemistry by C.N.R. Rao, and this is the Macmillan Publications book. Then third book, Physical Chemistry by R.A. Alberti Ville Esther Limited book. Then Elements of Physical Chemistry by P.W. Atkins and Oxford, and this book Principles of Physical Chemistry by Meron and Proton. At the first lecture of this paper, I have given this list of reference books. Then let us begin with our chapter Electrochemistry. Here, you know, electrochemistry, it is the branch of chemistry that mainly deals with the study of interconversion of electrical energy into chemical energy and vice versa. That means how the chemical energy it will get converted into electrical energy, and how electrical energy it will get converted into chemical energy. It is studied in the branch of physical chemistry, and it is termed as electrochemistry. You know, electrochemistry it begins with the study of electrolytic cell or electrochemical cell. And the construction of any cell it consists of a cell in which we have anode, that is positive electrode, cathode, that is negative electrode, and these two electrodes are connected by a source of electricity, that means battery, and these two electrodes are dipped in any electrolytic cell. As soon as we complete the circuit, the flow of electrons or migration of ions takes place, and it happens in the electrochemical cell. We see in detail later on. Again, you are very well familiar with the fuel cells, then lithium ion batteries, and the 2019 Nobel Prize. It is given to the three scientists, one from Japan and two from America, for their research in the lithium ion batteries. You may get a detailed knowledge regarding the 2019 Nobel Prize, so that you will understand what is the lithium ion battery, how they work, how they are fabricated. Okay, then chemical substances are of two types. First type, here it is electrolytes and non-electrolytes. Again, electrolytes are the substances that they can conduct electricity when they are in molten state or in a aqueous and undergo a chemical change. For example, ionic substances like dilute acid solution, dilute alkaline solutions, and molten salts. For example, NaCl, KCl, etc. And they conduct the electricity. These substances are called as electrolytes. And non-electrolytes, they are the substances, they cannot conduct electricity either in a molten state or aqueous state. For example, the covalent substances. Examples of non-electrolytes are naphthalene, sugar solution, latex, that means rubber, and hydrogen chloride in organic state. These are the certain non-electrolyte substances. That means they do not or cannot conduct electricity. Then here, in a solid state material, it cannot conduct electricity. and because the ions are held in a fixed crystal lattice in case of solid state. And here it is shown the lead iodide solid. In this lead iodide solid, the Pb2 plus ions and iodide minus ion, they are tightly or fixed in this lattice. They are held with the strong electrostatic forces of attraction and they are not free to move. So, the solids do not conduct electricity. Then, in a molten state, that means when we prepare a solution of solid, and here these are the ions in a liquid state. Here Pb2 plus ion, here iodine minus ion, and they conduct the electricity. That means in a molten state or in a aqueous state, the electrolytes, they conduct electricity, and this is because the presence of moving ions. The ions are free to move in the molten or aqueous solution. Then electrolytes and non-electrolytes. Here they classify the following chemicals into electrolytes or non-electrolytes. Here these are the some examples. Here potassium chloride, it is electrolyte. Molten lead bromide, that is PbBr2, it is also electrolyte. Again glucose solution, non-electrolyte. Trichloromethane, it is also non-electrolyte. Molten zinc, it is electrolyte. Sodium chloride, electrolyte. And ammonia in tetrachloromethane, it is a electrolyte. Then the process of electrolysis. That means when we have a apparatus, it consists of anode, cathode, then any electrolytic solution, and when these two uh, electrodes, they are connected through a battery, and when the circuit is completed, there is a migration of ions, and this migration of ions, it is called as electrolysis. The here electrolysis is a process of breaking down the chemical compounds into their constituent elements using electric current. For example, if we have a molten aluminum oxide, with the help of electric current, we have aluminum and oxygen gas. Then the another example, copper chloride, with the help of electric current, we have copper and chlorine gas. That is the electrolysis. Here, this is the electrolytic cell. As already I have told you, any electrolytic cell or electrochemical cell, it consists of two electrodes. These are the two electrodes. Here, this is our positive electrode, that is anode. This is our negative electrode, that is cathode. And suppose in this uh, apparatus, we have taken a electrolytic solution, and that electrolytic solution, it contains negative ion. We call that negative ion as anion, and here there are some positive ions. We call them as cation. Any electrolytic solution in an aqueous state, it consists of anion and cation. That means positive ion and negative ions. Here there are large number of positive ions and large number of negative ions. And in such a electrolytic aqueous solution, we have dipped cathode and anode. And here these two electrodes, they are connected with the help of battery. As this circuit is completed, the migration of electrons from positive electrode towards electrons, they get migrated towards the positive electrode, and positive ions, they get migrated towards the negative electrode. And this process, it is called as electrolysis. Remember well, the migration of positive ions towards negative electrode, that means cathode, and the migration of negative ions towards anode, this phenomenon, it is called as electrolysis. Then here, electrolytic cell. This is a set of apparatus needed to conduct electrolysis, and it consists of a battery, an electrolyte, and two electrodes. One is anode, another is cathode. Anode, it is the electrode which is connected to the positive terminal of an electric source. Remember well, anode, it is the electrode which is connected to the positive terminal of an electric source in the electrolytic cell, and cathode, it is the electrode which is connected to the negative terminal of an electric source in the electrolytic cell. And when we have a battery, two electrodes, one electrolyte solution, and whole it is uh, in a one apparatus, that is our electrolytic cell. Then here, what happens during the electrolysis? Anode, it is a positive electrode, cathode, it is a negative electrode. Anions, that means negative ions, will be pulled towards the anode. That means positive electrode, towards the positive electrode. In simple words, the migration of negative ions towards positive electrode takes place. And here cathode, it is a negative electrode, and migration of positive ions towards cathode takes place. Here cations means positive ions will be pulled towards the cathode. That means cathode, it is our negative electrode. Then at the anode, anions will be discharged by releasing the electrons to the anode. At anode, what happens? Anions will be discharged by releasing the electrons to the anode. And at cathode, cations will be discharged by receiving the electrons from the cathode. These are the two phenomena which occurs at the anode and cathode. And you know, the loss of electron or releasing of electrons, this phenomenon, it is called as oxidation, and it takes place at anode, while the gain of electron or receiving the electrons, it takes place at cathode, and this phenomenon, it is called as reduction. In short, the oxidation means loss of electron or releasing of electron, it takes place at anode, and gain of electron, it takes place at cathode. This phenomenon is called as reduction. In short, oxidation occurs at anode and reduction occurs at cathode. Here there are some examples of electrolysis of molten compounds. Here example, you know, this is our anode, here it is our cathode, and suppose we have a molten potassium iodide, that means a aqueous solution of Ki. Then during the electrolysis, here the K plus ions, they get migrated towards the negative electrode, that means cathode, and I minus, they get migrated towards the positive electrode, that is anode. This is the electrolysis of molten potassium, and when the iodine minus ion, it comes at the anode, it releases electron, and these electrons, they get accepted at the cathode, and here we have a reduction of K plus ion. Remember? Then the next example, here suppose we have a zinc oxide solution. That means in our solution, suppose we have Zn plus plus ions and Zn plus plus ions and oxygen minus minus ion. Then the Zn plus plus ions, they get migrated towards the Zn plus plus ions, they get migrated towards the cathode, and the oxygen, they get migrated towards the anode, positive electrode. Then here suppose we have the molten lead bromide. Again the same case takes place. Positive ions, they get discharged at the cathode. Negative ions, they get attracted towards the positive electrode. Then the another example, molten lead oxide, the same case happens. Then in case of zinc chloride also, we have the discharge of Zn plus plus ions and Cl minus ions, they get migrated towards the anode. Then next example, we have the molten PBr. Okay, then as already you have studied the examples of electrolysis, what happens at the cathode, that means negative electrode. Then the remaining points we will see later on.